Unit 3.2, Implicit Differentiation. So if you recall, an explicit equation is y equals x squared. An implicit equation is y equals e to the power of 2xy. Chain rule and implicit differentiation. In terms of x, so the derivative of x is 1, derivative of x squared is 2x, and the derivative of e to the power of 5 of x, we apply the chain rule. So this would be e5x multiplied by the derivative of 5x, which is 5. And the derivative of e to the power of 5x is 5e to the power of 5x. In terms of y, we can say y prime, or instead of y prime, we could say dy dx, 2y dy dx, and we apply chain rule, so e5y multiplied by derivative of 5y, which is 5 dy dx. Or we could just, actually let's write it as y prime. Sorry about that. Y prime, 2y, y prime, and 5y prime. So this equals 5y prime multiplied by e to the power of 5y. An example. Find dy dx for y squared equal minus 5x cubed equals 3y. So step 1, take the derivative, and each time the derivative of y is involved, include a dy dx. So the derivative is 2y dy dx minus 15x squared equals 3 dy dx. Step 2, gather all terms with dy dx on the left side, everything else on the right. So we bring this to the left and this to the right, and it'll be 2y dy dx minus 3 dy dx equals 15x squared. Factor out the dy dx if necessary to create only one dy dx term. So we can factor our dy dx here. Multiplied by 2y minus 3 equals 15x squared. Then solve for dy dx. So you divide this on both sides, and dy dx equals 15x squared over 2y minus 3. Number 1, our first example, y cubed minus 2x equals x to the power of 4 plus 2y. First, we find the derivative, so 3y squared dy dx minus 2 equals 4x cubed plus 2 dy dx. Bring all dy dx to the left side and everything else on the right side. So 3y squared dy dx minus 2 dy dx equals 4x cubed plus 4. Oh wait, no, that's not right. I'm sorry. Plus 2. Factor it out. Dy dx multiply 3y squared minus 2 equals 4x cubed plus 2. And then you find dy dx equals 4x cubed plus 2 over 3y squared minus 2. Number 2, sine of xy equals 10x. Find the derivative. Right here you have to apply chain rule. So this will be cosine of xy, since there's a y here. I'm sorry. Sorry. Cosine xy multiplied by derivative of xy equals derivative of 10x, which is 10. So this will become cosine xy multiplied by y plus x dy dx equals 10. Then you bring all terms with dy dx on the left side, everything else to the right side, which will be x dy dx equals, since you're dividing by cosine, you could just say it's 10 secant of xy minus y, and you divide it by x, so dy dx equals 10 secant xy minus y over x. Derivative at a point, implicit differentiation. Find the equation of all tangent lines for x squared plus y squared equals 4 when x equals 1. So first, know that we have to find the tangent lines, so these lines, when x equals 1. First, let's find our points. So we know that x values right here are 1. We need to find the y value, so we'll plug 1 back into the equation. So 1 squared plus y squared equals 4. 1 plus y squared equals 4. Minus 1, y squared equals 3. Square root y equals plus minus square root of 3. So we know that the y value right here is square root of 3, and the y value right here is negative square root of 3. Now that we have our points, we can start working on finding our slope of our equation. So to find the slope, we need to find the derivative. So the derivative of this equation is 2x plus 2y dy dx equals 0. We go through the same process as we have before, and then we'll find that dy dx equals negative x over y. So we plug in our values, and we'll know that our slope is negative 1 over square root of 3. And then, since we have two different points where it touches x equals 1, we'll have two different equations, both with one with a positive slope and one with a negative slope. So our two equations are y minus square root of 3 equals negative 1 over square root of 3 multiplied by x minus 1. And our other equation is y plus square root of 3, since it's a negative square root of 3, equals positive 1 over square root of 3 multiplied by x minus 1. Horizontal and vertical tangent lines. Horizontal tangent lines exist when Horizontal tangent lines exist when the slope dy dx equals 0, and vertical tangent lines exist when the slope dy dx is undefined. So right here, find all horizontal tangent lines of the graph 3x squared plus 2y squared equals 16. So first we have to find the derivative. This will be 6x plus 4y dy dx equals 0. Simplify this out. This will be dy dx equals, not simplify, I mean solve 3x over 2y. Now that we know what the derivative is, we could start by figuring out what the x value is. So in this case, once negative 3x equals 0, so x equals 0, and then once we have that our x equals 0, we plug 0 back into the equation. So 0 squared plus 2y squared equals 16. Y squared equals 8. Square root y equals positive negative square root of 8. And this is our answer. That's where our horizontal tangent lines are. Now 5, find all vertical tangent lines of the graph. First, we will start by finding the derivative. In this case, we already have, so we already know that it's 3x over 2y. And we know that vertical tangent lines exist when the slope dy dx is undefined. And to make it undefined, the y value, the denominator, has to equal 0. So we'll plug 0, since y equals 0, we'll plug 0 back into the equation. So it'll be 3x squared plus 2. 0 squared equals 16. And we can find that to be x squared equals 16 over 3. And then that'll be x equals positive negative square root of 16 over 3, or positive negative 4 over square root of 3, depending on if you want to simplify 16 or not.